Good morning, students. This lesson is of class 8 for the subject of physics. Topic for today is Newton's third law of motion, which is covered in chapter 3, Laws of Motion, and is on page number 71 of your physics book titled Concise Physics by Selena Publications, and is being submitted to you on 2nd August 2021. So children, now let us start with our topic for today, that is Newton's third law of motion. Children, before starting our topic, let us recall one important concept which we have already learned, that is Newton's first law of motion is also known as qualitative law of force. And Newton's second law of motion, it gives the quantity of force applied on a body. Now children, second law of motion is also known as real law of motion. So children, first of all, I want you all to observe figure number 1. In this figure, there is a horizontal surface and a box is lying on the surface. You can have a box on the floor. Imagine a box lying on the floor, a horizontal surface. Now children, which kind of force is required to move this body? Write down the answer in the textbook. What kind of force is required to move this body? Is it the force to bring the box to rest, or the force is required to bring the box in motion? And if this box is of mass 5 kilogram, the mass of the box is 5 kilogram and acceleration produced is 2 meters per second square, then how much means quantity. How much force is needed to move this box? So now you may pause this session and write down the answers in your physics notebook. So children, I hope you must have written your answers by now. Children, to move an object, I need to apply a force to bring the box in motion. So for first part, option B is correct. And for second part, I know the formula of force. According to second law of motion, it is mass into acceleration. So mass is given to be 5, acceleration is 2 meters per second square. So we'll have force of 10 Newton. So first law is telling us that we need to apply a force to move the body. And second law is telling us that we need to apply a 10 Newton force to move this body with an acceleration of 2 meters per second square. Is it fine? So I hope this much is understood. Okay, very good. Now children, the next question which comes in mind is, we know that we have to apply force. We also know how much force we need to apply. But children, do we know that in which direction the force is to be applied? Force is a vector quantity. It depends upon direction. But till now, I have not told you whether we have to apply the force towards right side or towards left side or in an upward direction or in downward direction. You don't know that you are applying the force towards left or towards right, downward or towards upward direction. So this is yet not known to us. So children, this question cannot be answered by both the laws which we have studied, that is Newton's first law and Newton's second law of motion. So these two laws do not explain how the force acts on the body. While this question is answered by third law of motion, Newton's third law of motion. And what is its statement, children? Let us understand. To every action, there is always an equal and opposite reaction. Children, action is also a kind of force. Reaction is also a kind of force. So whenever you are doing any action by applying a force, you will get a reaction which is equal, whose value is equal as that of action, but its direction is opposite. So we'll get these things clear in our examples. So children, be attentive now. Now see, if you're having a ball, suppose you are having a basketball, and if you dribble this ball, so this ball will come down and rise up, no doubt. But if you throw the ball or you leave your hand from the support of this ball, the ball will fall down. Similarly, you are having a book lying on the table. Will this book fall down? Will this book be falling down? Will it break this table and go down? The answer is no. And I have told you this in first exercise when we studied about contact forces. So children, the ball falls down on the floor because its weight is acting down. In case of book, the weight is still acting down, but there is an equal and opposite reaction, normal reaction. Remember, reaction is given by the table. The table is given force of reaction on the book. And this reaction, normal reaction, is equal to the weight of the book. So children, action was the weight of the book. Reaction is the table giving a reaction in an upward direction. So both are same. If weight of the book is 10 newtons, if weight of the book is 10 newtons, the weight of the reaction and force given by the table, the reaction force given by the table is also 10 newtons. So children, this in figure 3, you can see the whole setup. I have explained all the kinds of forces applied on a table as well as on the book. So now let us understand how we are able to walk. This is a very important example, children, how you are able to walk. So children, first of all, I request you all to stand up and try to move in a forward direction. Let us do it slowly to understand the forces acting and their directions. Children, when you walk, firstly, what happens? You do one thing, bring your right foot forward. Right foot forward as shown in figure 4a. See, this is your left foot and this is your right foot. So let us bring your right foot forward as shown when initially your left foot is already ahead. It is already ahead. In doing so, kindly note and observe the force you are applying on the floor. Children, in this case, in 4a, what is happening here? This is force. When you are pushing, when you have to move forward, you are pushing the floor backward. What you are doing? See, you are pushing the floor in a backward direction. Try, see what you are doing. your feet is pushing the floor in a backward direction, and in the similar manner, the force is applied by the floor on you. The floor is giving you a reaction in a forward direction. This is the way we walk. We always push the floor backward with certain force. And in the meantime, the floor also exerts a force on us in an opposite direction. This is how we work. Now, similarly, children, there are few questions which I'm giving you. How does a rock climber climb a rock? By using a rope hanging vertically downward. So here is a rope and there is a rock ahead, and you want to move up. So this is the rock person. What he do? He has to pull this rope downward to move in an upward direction, isn't it? Okay, students. Similarly, how do you swim in a forward direction in a swimming pool? Are you pushing the water forward or backward? Imagine your answers and then write down in the notebook. So students, when you are swimming in a forward direction, you push the water backward. Only then you can move forward. Children, while writing down the answers of all such questions, what you have to do is you have to write down separately what is the action, pulling the rope, and in which direction? Downward. What is the reaction? You are moving in an upward direction. So always remember, in laws of motion, third law, you have to always write down action and reaction separately and give the directions also. So children, further, there are many such examples in your textbook also, and I want you all to go through this animated part so that you are able to understand what is law of motion. So children, we are studying Newton's laws of motion. To every action, there is equal and opposite reaction. See, now what is happening here? The force, this ball has fallen on a table. So the ball is applying a force on the table. And in the similar manner, the force is applied on the object. As we discussed in terms of work, this is for the case of the ball falling on a table or on a floor also. The same thing happens, students. So need not worry. So further, after this ball concept is clear, when two bodies interact with each other, force on each objects are equal. So what do we mean? That force applied on the table, that is action, is equal to force on the object, that is reaction. Now children, see what is happening here. This is a frog. He is moving up ahead. He is moving in a forward direction. When he is moving in a forward direction, see, his legs will be pushing the water in backward direction. Okay, so let's have a look. See what he's doing. When he brought his legs forward, then he pushed the water in a backward direction. I want you all to pay attention. See, now what he is doing, he is pushing the water forward, backward. So when he is pushing the water backward, that is action. And then the water in itself applies force on it, that is reaction. The water is giving reaction to the action of frog. So I hope this is clear. Now see, there is a bird on the right side. What he is doing? Children, this bird is flapping its wing downward. So throwing the air in a downward direction. And what will happen? In return, the air will apply force in upward direction. such that this bird can fly upward. Okay. So every action has equal and opposite reactions. Now this is a case of bullet. It is given in your book also. So if you are having a gun and in this gun, there is a bullet and you take a shot. You trigger the bullet. Then what happens? See, the force of the bullet is a forward direction while your bullet, listen children, your bullet moves forward with certain force while this gun, it recoils. Recoils means it goes back. It will go back with a little jerk. So the action is triggering the gun such that bullet comes out. But what is the reaction? The bullet going in a forward direction is action. The gun going in backward direction is your reaction. I hope this much is clear. So if you take a shot, see what happened? A little, there is a very little deflection here, children. So you have a look. See, if the bullet comes out. So did you saw it? When the bullet came out, the gun recoiled in a backward direction. So it gives a jerk in a backward direction. So I hope this example is clear to all of you. Coming further, that is, this example is also very important, children. When you step outside a boat, you want to come outside the boat. You know what happens? What do? You push this boat backward. That is your action. So action is pushing the boat in a backward direction. That is action. And reaction is the boat pushes you in a forward direction. It is the same case as that of floor. You push the floor backward, the floor give you a forward direction. It allows you to move in a forward direction. So look here, children. So see, when this person is moving out, what he is doing? He's pushing the boat backward, and the board will allow it to move in a forward direction. So in this way, you will be doing the questions and the applications of Newton's third law of motion. So I hope the concept is clear through these interesting videos. So children, with this, I conclude this interactive session, and you may please write down the answers of question number 1, 2, 4, 7, 9, 10, and 13 of your exercise 3D given on page number 73 of your physics textbook. Children, the answers to all the questions can be easily found between page number 71 and 72. And children, you all have to solve the remaining numericals of exercise 2C also. So I hope Newton's third law is clear to you all. So that's all for today's students. Thank you and have a very nice day.